Shoe. Um, Looking at the fourth question, supplementary again. So you are given a hyperbola. Check out the one that I speak about, the changing of the hyperbola. They like those type of questions where you have something like this, x plus 1 all over x plus 4, right? That's a hyperbola. Check out the clip where you switch and make it into its original form. So you are given the hyperbola. So the first question was to write the asymptotes of G. The asymptotes for this y is going to be equal to q. This q. And then you have x being equal to a different sign of p. And then the second question, calculate the y-intercept. Okay, y-intercept, x equals 0. So I have g at 0 equal to 6 over 0 plus 2 minus 1. This gives you a positive 2. So the y-intercept is 0, 2. And then you have x-intercept. The value of y equals 0. So 0 being equal to 6 over x plus 2 minus 1. Then the 1 gets outside. Then you have x plus 2 being equal to 6. Therefore, the value of x is 4. So you have 4 is to 0. Those are the x-intercepts. So getting to sketch. I told you when you're sketching, the first thing you need to know is the shape, any function. The second thing is the what? Asymptotes, if they are in. And the third one is intercept. This is all the three is what you need to sketch. If you don't know this three, you won't be able to sketch. But you need to have these ones in check. So the shape for the hyperbola, the shape, because of its y is equals to a all over x plus p plus q. The shape is determined by a. So if a is positive, a is positive, right? That's what we have here. A is a positive. When I have a shape like this, that's a decreasing function. So I'll go and start with the asymptotes rule. My asymptotes is x is equal to 2. Here's x is equal to 2. So I'm going to have times this. Graph doesn't touch this. And then I have negative 1. Graph doesn't also touch this line here. And then followed by the intercepts. I know the intercept is 4 to 0 and 0, then a 0 and 2. Then this one comes to the side. And this is G. You showed intercepts clearly and the function. Determine the equation of the line of symmetry that has a negative gradient. Axis of symmetry, axis of symmetry, axis of symmetry. axis of symmetry with a negative gradient. Gonna take this thing here, right? So it's gonna be negative gradient. So y is equal to negative x plus 2, then minus 1. This minus 1. So I took all this thing here, all of that. Then I have negative x minus 3. That's my equation. And then fifth question is to find the values of x for which this is greater or equal to negative x over 3. This is the axis of symmetry, right? This is the function. So I'm gonna look where the function is what? Above. Right here, this one has to be below. So a very good thing to use will be having it on the Cartesian plane. If I look at the one with the negative gradient, I know it cuts at negative 3. I know the y-intercept also is negative 3 because this is C. So it's going to also pass the intersection of the asymptotes. Is this moving? I'm gonna move the line, please. There we go. Above. There we go. Yeah, perfect. So that's our line. So we need to look at critical values here, right? So a very important thing to check on is this thing. Where is G above? If I look at G, it's above in this realm here. This is where it's above. In this realm here. That's where it's above. Right? And then this one here is below. You can see this is below. This is below. So from where? From this point here, the asymptote, from the asymptote. After the asymptote, immediately after the asymptote, the graph, it's below y is equal to negative x plus 3, I mean minus 3. So I can therefore conclude that x has to be greater than 2. That is where G is above the axis of symmetry.